Question 34. A discrete random variable has probability distribution as shown in the table where n is a finite positive integer. Show that the expected value of x is equal to n outside of. The expected value of a discrete probability distribution is found by summing the product of each score with its respective probability. So in this case, the expected value of x is equal to r multiplied by r to the power of n. So that's the product of the terms in the first column, plus r squared multiplied by r to the power of n minus 1. So that's the score in the second column multiplied by its respective probability, and so on. And there are n terms to sum here. So simplifying all this, we end up with the expected value of x is equal to n multiplied by r multiplied by r to the power of n. Since we can use basic index laws to express each of these terms in terms of r and r to the power of n. So r squared multiplied by r to the power of n minus 1, if you add the indices, that's r to the power of n plus 1, which is just r multiplied by r to the power of n. Hence why we come up with this equation here. The expected value of x is equal to n multiplied by r multiplied by r to the power of n. Now the next point to note is that being a discrete probability distribution, the sum of the probabilities, so that's the sum of the second row in that table, must equal 1. And so the terms in the second row are r plus r squared plus r cubed plus dot 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 plus r to the power of n. So these are the probabilities in the second row, and they must sum to 1 for a valid discrete probability distribution. Now this happens to be a geometric progression. First term is r and a common ratio of r, and the sum of n terms is equal to 1, being a discrete probability distribution. So using the sum to n terms of a geometric progression formula, that's the Sn equals a outside of 1 minus r to the power of n over 1 minus r, and just substituting in r for a as the first term, and a common ratio of r, and the sum to n terms is equal to 1, we have 1 equals r outside of 1 minus r to the power of n over 1 minus r. So that's the sum of the p x equals x row. And we'll call that equation number 2. So what we're going to do is then equate equations 1 and 2 together and make e of x, or expected value of x, the subject of the formula. So from equation number 1, I've rearranged this equation slightly. So e of x, or expected value of x, over nr is equal to r to the power of n. Because I want to eliminate this r to the power of n term. Because in the end, the answer is in terms of 2r or 2r minus 1. There's no r to the power of n. And we're going to sub this into equation number 2 for r to the power of n. So we're going to replace this term here, r to the power of n, with ex over nr. And so from equation number 2, and I've multiplied both sides by 1 minus r as well. So we have 1 minus r is equal to r outside of 1 minus expected value of x over nr. So 1 minus r is equal to r minus expected value of x over n. So that's multiplying through by r. We're expanding the brackets here. So this r and this r here will cancel. And then multiplying all terms by n to eliminate the fraction, we have n minus nr is equal to nr minus e of x, expected value of x. And I've just reversed the terms. So ex minus nr is equal to nr minus n. So I've also flipped sort of each side of the equation around just to make ex the subject, or eventually it will be. And then adding nr to both sides, we end up with expected value of x is equal to 2nr minus n. And then factorising out the n, we have expected value of x is equal to n outside of 2r minus 1 as required.